All right, let's dive right in. Have you ever looked at a massive smart building? I'm talking airports, university campuses, huge office complexes, and just wondered, how does it all work? How do all those systems run smoothly without turning into total digital chaos? Well, you're in the right place. Today, we're going to pull back the curtain on KNX and build a smart network from the ground up, virtually, of course.
So let's start with the big question, the elephant in the room. Imagine for a second you're responsible for a building with tens of thousands of smart devices. You've got lights, blinds, heating, security systems, you name it. They all need to communicate. But what happens if every single device starts shouting its status at the same time? Well, you get a massive digital traffic jam. The whole network just grinds to a halt. So how on earth do you solve a problem of that scale?
Here's the game plan for how we're going to tackle that. First, we'll dig into that network challenge. Then, we'll lay the physical foundation. Got to start with the basics. From there, we'll build out the KNX hierarchy, meet the little devices that act as traffic cops, figure out how everything gets a unique address, and then, the best part, I'll show you how you can get your hands dirty and start building your own virtual network today.
Okay, first up, really understanding this challenge. We're talking about a potential communication overload. See, the problem isn't just about connecting a bunch of devices. It's about making sure that messages get sent efficiently, and, this is the crucial part, only to the devices that actually need to hear them.
And the scale we're dealing with here is just massive. A single KNX installation can handle, in theory, up to 61,455 devices. Just let that number sink in. Without a super smart, super structured system, it would be absolute chaos. And this is exactly why the network's topology, its fundamental architecture, is so incredibly important.
So before we can even think about the logical structure, we have to start with the physical layer, the real-world stuff. And it all begins with one single, humble wire, the KNX bus cable. This thing is literally the central nervous system for our entire smart building.
Now listen, you can't just use any old electrical wire for this. KNX twisted pair, or TP installations, need a very specific standardized cable. It's a shielded, twisted pair cable designed purely for sending data, not power. And the rules are super strict. You absolutely, under no circumstances, use standard mains cables for the bus line. That's a huge no-no for both safety and for making sure that data doesn't get corrupted.
So, why all the fuss about this one cable? Well, it all comes down to a critical safety concept called SELV. That stands for Safety Extra Low Voltage. All it really means is that the KNX bus runs on such a low voltage, and it's so well isolated from any high-voltage circuits that the risk of getting an electric shock from it is practically zero.
And here's the real-world payoff for anyone installing or working on these systems. Because it's a SELV circuit, technicians can handle the bus line itself without needing any special safety gear or precautions. It just makes the whole process of installation and troubleshooting fundamentally safer and a heck of a lot easier.
Okay, our cable is laid. We have the physical foundation. Now let's get to the really cool part, the logical architecture. KNX organizes everything into this beautiful, scalable hierarchy. This, right here, is the secret sauce to taming all that network traffic.
The easiest way to think about it is like this. The smallest building block is called a line. Just picture that as all the devices on a single floor of an office building. Then you can group a bunch of those lines together to form an area. That's our whole building. And finally, you can connect multiple areas or multiple buildings with a high-speed backbone. Now you've got a whole campus-wide network, or a domain.
And this structure has very specific hard and fast rules that let it scale up so big. A single line can have up to 256 devices on it. An area can bundle together up to 15 of those lines, and the main backbone can connect up to 15 areas. You start to do the math, and suddenly you can see exactly how we get to that mind-boggling number of over 60,000 devices.
So we've got this awesome hierarchy of lines and areas. But how do they talk to each other without just flooding the entire system with noise? For that, we need to meet the gatekeepers. These are the unsung heroes of any stable KNX network, the couplers.
There are two main jobs here. A line coupler connects a regular line, our floor, to the main line for that area. An area coupler connects the entire area, our building, to the main backbone. But here's the really clever part. It's the exact same piece of hardware. Its job is defined purely by where you put it in the network.
Put simply, the best analogy for a coupler is a smart traffic cop.
It stands right at the intersection between different parts of the network, and its whole job is to direct the flow of information, making sure there are no crashes or traffic jams.
So what do these little traffic cops actually do? Well, first, they electrically isolate the lines, which is a nice safety feature. But their main job, their superpower, is filtering messages, or what KNX calls telegrams. If someone flips a light switch on floor 1, the coupler makes sure that message stays on floor 1. It doesn't get broadcast to the entire building. This keeps the network incredibly fast and efficient. Messages only go where they're needed, period.
Okay, so we've got the physical wire, we have the logical structure, and our traffic cops are on duty. Now, how does a device actually know where to send a message? Well, it all comes down to a really logical and pretty intuitive addressing system.
Now, KNX gives you a few different ways to structure these group addresses, which are what devices use to talk to each other. You can see there's a 1, 2, or 3-level system, but honestly, by far the most common, the most powerful, and the one you're going to use 99% of the time is the 3-level address structure. It just gives you so much more organizational power. Let's break down how this works with a real example. Imagine you see the address 1/0/1. The first number, the main group, could represent a physical space, like the main floor. The second number, the middle group, could define the function, like lighting. And that last number, the subgroup, pinpoints the exact group of devices, like the ceiling lights. So when a command goes to 1/0/1, you know exactly what's happening. You're controlling the ceiling lights on the main floor. It's clean, it's readable, and it's super organized.
Wow. Okay, we have covered a ton of theory, from the physical cable all the way up to these logical addresses. So the big question is, how do you take all this knowledge and turn it into a real skill without, having to buy a bunch of expensive hardware? Well, the KNX Association itself has the perfect answer. It's a tool called KNX Virtual. And you don't have to take my word for it. They say it lets you build and test a complete smart building installation right on your computer without spending a dime on physical gear.
Think of it as your personal digital sandbox. It's your lab. It's the place where you can apply everything we just talked about, creating lines, setting up couplers, assigning group addresses, and actually see how it all works in practice. It is, without a doubt, the best first step to building real confidence and expertise.
So there you have it. We've laid out the entire blueprint for a powerful, scalable KNX network. We've seen how it brings order to what could be tens of thousands of devices. The only question left is, now that you know the blueprint, what amazing smart space are you going to build first?